record. All right. So we've got a function, determine the intervals on which the function is concave up or concave down. Anytime you see concave, that the indication should be that you need the second derivative. So we need to find f prime first. Terrible X. So just do your power rule. So it looks like 6x squared minus 24x minus 1. Then find the second derivative. That's going to be 12x.
Wouldn't it be 48x
Yeah. Thank you. Yeah.
instead of 24x in the original derivative equation?
Oh, sorry about that. I haven't had my beer yet. There we go. All right, so then we need your inflection points. So to do that, you set this guy to 0. So 12x minus 48 equals 0. Factor out of 12. Get x equal 4. That's your inflection point. That breaks up your number line. So we've got 4 there. Pick a test point on both sides. This is a polynomial function, so its domain at the beginning is negative infinity to infinity. So if I test these points, right, I plug 3 in here, this thing here becomes, or this guy here becomes negative. So this is minus, and then if I plug in 5, I get plus. So I am concave up from 4 to infinity and down minus infinity up to 4. Go with that one.
Wait, what'd you plug it into again?
I plugged, you talking about the 3 and the 5? Where did I plug those?
Yeah.
You plug those into.
Oh, okay.
So you could use this form if you wanted. I chose this one because it's real easy, because I don't care what the number is. I just care about the sign. So that's really the best form to plug it into. In part B, locate points of inflection. Well, we've only got one of them. And the inflection points when we technically change from concave up to concave down. So it does say to find the ordered pair. So we have x. We need to take that and plug it back into the original function, which was 2 times 4 cubed minus 24 times 2 squared. Oops, that's a 4, not a 2. Hey, the eraser worked properly that time. 4, 7. How'd that disappear? Come on. There we go. So what's that come out to be? I don't know off the top of my head. Four times 2 minus 4 times 16 plus 7. So it's negative 253 if I didn't do something silly there. So ordered pair 4, negative 253. nice that stayed with it there. I don't know. As I say that, the negative 253 gets shifted. Should be a right up there. All right. Assuming you're just going to tell me to go ahead and do number 2 at this point.
Yep.
Yeah.
Keep going.
Yeah.
Number 2.
All right.
Woo.
Concave up, concave down again, and inflection points. So same thing. The only difference is now we've got a quotient that we've got to deal with. So again, let me make some space here.
Alrighty.
So we've got to find f prime. That's going to be low times d high minus high times d low, all over the denominator squared. Let's see. I noticed there's, can you guys see my little cursor here on the screen?
Yeah.
Okay. So I noticed there's a 2 in common of both of these terms. I'm gonna
Oh wait, no, we can't.
Oh, you can't see that little
No.
pen?
No, I thought you meant the.
No, not
No.
the blinking one down there.
Yeah, no, we can't see the other one.
Gotcha. All right. So
Oh,
Now
yeah,
we
we
can.
can.
yeah, I want to
Yeah,
take a 2 out of these two terms. And there's also a 4. So I'm going to take a 4 and take 2 out of this and factor it out of everything. So basically I'm taking out an 8, right? A 2 times 4. So and rather than multiply all that stuff together, I'm trying to factor it now. So if I take out a 2 and a 4 out of this, I'm going to be left with, actually take a negative out. So this will be x squared, right? Because if you think about it, this is, this would be negative 8x squared.
Oh, yeah. Okay.
And then if I multiply these two together, that would be a plus, what, 32. So if I take out an 8, it would really be minus 4 here. And then we've got a negative in the middle. And I'm taking out a negative 8 out of these two. So this is really negative 16. I take out a negative 8, that leaves me back a 2. And there's x squared there. After doing that, I feel like it was probably more complicated than it needed to be. You can obviously multiply it all out and
Little.
do it the way you want. Let's see. So we've got x squared minus 2x squared up there. So this is going to be minus x squared minus 4. Then down here. So again, I'm going to take out a 2 out of this. I guess I'll do this in 2 steps. So if I take a 2 out, it would look like this. So if I want to take it out of the parentheses completely, I'd have to square it, and it would become a 4. Everybody okay with that?
Yep.
Wait, what?
I say that was somewhat inaudible. Were you asking what was Gianni saying, or what did I do?
What did you do?
So are you okay with this guy right here where I said I have a 2 in common? I factored out
Yeah.
the 2. And so that gives me x squared minus 4 there.
Yeah.
And then I have this squared here. So if I want to take this guy outside, I have to square it. So he
Okay,
becomes
I got
4.
it.
And then this
I got
guy
it.
is still squared.
What?
Okay.
How'd you get the numerator?
So what I was saying is if you want, you can multiply this stuff all out. Uh-oh, running out of time already. We've removed the 40-minute time limit on your group meeting. Fantastic. Good choice, Zoom.
It says on my computer it was upgraded.
All right. Well, I had emailed them asking for, I requested getting a license because they're making it free for K through 12, but not for colleges for some reason. So yeah, I'm waiting to hear back from them for that. All right, so let me just multiply this top out real quick so that we all see it. This is minus 16x squared plus 32 minus, it's going to be a minus 16x squared. Unless I'm losing my mind here. Let me see. Yeah, I'm losing my mind. This is only an 8. All right, we okay with that?
Yep.
Okay. So now if I simplify that, this is a plus. So total I get, looks like maybe I had my sign wrong. Let's see. 8x squared plus 32. Those both have an 8 in common. If I take it out, I get x squared plus 4. No, I have my sign right because I have a negative there. I have a negative here, a negative here. If I factor out all the negatives and multiply by that one, everything becomes positive. Basically, I could just do that. Okay, so all that being done, unfortunately, only thing that we can cancel is this and make that a 2, and that's only the first derivative. Woohoo! So we've still got to find the second derivative. So low now we need derivative of high. So that's going to give me 4x minus high. I'll go ahead and just multiply this back in, I guess. We need derivative of low. That is 2 times the quantity, x squared minus 4 to the first power, times the derivative of the inside because it's a chain rule.
Oh my god.
Did you say, oh my God? Jake, we lose you?
What's
Go
up?
ahead. Go ahead.
Nothing. I'm just. That's a lot.
So a lot of you guys are being quiet. Are you okay? Are you bored? Do you understand what's going on? You don't care? Give me something.
We're good.
Good.
In the zone.
John.
So now, try and simplify this guy. This actually has to be fourth. Okay, so notice we've got x squared minus 4 in this term, x squared minus 4 in this term. I'm going to cancel one of those, that one, and one of these. And that's going to make this a 3. I also have a 4x here and a 2x. That means they have at least a 2x in common. If I take that out, I have a 2 left behind in the first term times an x squared minus 4. And the last term here, I've taken out the, actually, you know what? There's another 2 here that makes that 4x. So let's factor out a 4x. Okay. Just keep this guy over. So this is x squared minus 4 minus, we've taken out the 4x already, so we just got 2x squared plus 8. All over this. And now, after this excessive amount of algebra, I've got x squared minus 2x squared, that's minus x squared. Negative 4 minus positive 8. 12. It doesn't let me write off the screen, darn it.
What did you just do?
Where? Just right here.
Yeah.
I just did x squared minus 2x squared. That's negative x squared.
Oh.
Negative 4 minus 8.
Could you not cancel that out?
Cancel what
That
out?
the x squared minus 4 on the numerator and make the denominator to the second power?
No, because there's a subtraction here. We've
Okay.
already done that, right? We went back here and we said each term, this one, and the bottom all had an x squared minus 4. So I got rid of one there, and then one there.
Okay.
Then I factored out stuff, so this can't cancel any longer.
Gotcha.
And then I'm just going to take a negative out here. All right. So that's about as simplified as I can make it. And yes, unfortunately, that is pretty much required in order to solve the problem. We need to eventually get, of course, it's come on. There we go. All right. So the whole point of the problem is to set this darn thing to 0. Where that 4x went, this is down here. Okay. So that means negative 4x is 0, gives us x is 0. That means x squared plus 12 could be 0. That's complex solutions. That's not going to help us. And then x squared minus 4 quantity cubed could also be 0, because remember, inflection points can be when the greater than 0 or when the denominator is 0, because you can have undefined. So that gives us,
What just happened?
with the scroll, you mean?
No, did anybody else hear that with his mic?
Yeah, your audio
That
went
was
crazy
wild.
for a moment.
I almost bled my ears out.
That bad, all right.
You know when people put their mics in their mouths
It's all
before some
good.
things? That's what it sounded like.
It was really bad.
Sorry to disappoint. I was not eating my microphone. Okay. So 0, 2, and negative 2. We can finally make our darn number line.
Wait, where the hell did you get all those numbers from?
I made them up.
That's what I thought.
I solved all these pieces here, right? I said that this is my second derivative. Negative 4x could be 0. This x squared plus 12 could be 0.
Oh, all right, I
That
got
doesn't give
you.
me anything good, and that's 0.
All right.
So that one you would take the cube root. The cube, this 3 goes away. Move the 4 over. Take the square root of both sides. You get 2 and negative 2. So I don't know if that was a good idea to spare you of some of that algebra, but I did. Got my test points, negative 3, negative 1, 1, and 3. So if we plug negative 3 into the original equation, what do we get? Well, the outside becomes positive. Let me just do 1 here so we see what I'm doing. Negative 4, I'm plugging negative 3 everywhere. Okay, so the nice thing is that this part right here, regardless of what number I plug in, is always going to be positive because I'm squaring it and then adding a number to it. So I really only have to care about the other two pieces. This combination is a positive number. Squaring a negative number there becomes positive. This number is bigger than 4. So overall, the whole bottom is positive for that one. So this guy right here is positive. Then plug negative 1 in. So that time the bottom's going to be negative. If I plug 1 in, the bottom's going to be negative, but so is the numerator. All right, so if we do that one, we had negative 4, plug positive 1 in. Again, this part's already positive. And then plug 1 in here. This down here is negative. This results in a negative. Negative divided by negative is a positive. And then finally plug 3 in. Bottom's positive, top is negative, overall negative. Guys follow that?
Yeah.
Yes, sir.
All right. So
To the best of my ability.
good answer.
Thank you.
Up is minus infinity to negative 2 and 0 to 2, and then down -2 to 0, 2 to infinity. The one thing I want you guys to be careful of is, and I see it all the time, is when you're doing your up and down, the numbers here that you use got to be your inflection points. Right, because what I see a lot of times, people go, oh, it runs from -3 to, I don't know, -1 or something. By accident, they'll use their test points. So be cautious of that. That's that answer. Personally, I don't think it would be too beneficial to do this part. We already did one. It's just plug a number in and chug.
Wait, can you go back up so I can take a picture of it?
Good idea.
I mean, you could just do a print screen on your computer.
Oh, goodness. Your mic again.
Can you go up a little bit more, please? Thank you.
That help?
Maybe one more.
One more what?
Zoom out.
Goodness.
All right. Any other problems you want to look at?
Oh, there you go.
3.
You're just trying to make me do this thing in its entirety, aren't you?
Can we do 4, 2?
And then maybe 5.
What does 4-2 mean? You want me to do 4 twice? Number 42?
No, like 4 as well.
I was kidding.
Hey, how come your camera's flipped upside down?
Because I remember I told you I'm using my Surface Book.
Oh, yeah, that's right.
So I flipped it over so that I could write on it easier.
Oh,
I have it propped up like a triangle right now.
that's a nice view.
Yeah. What is it, going right up my nose or something? Is that what you're joking about?
Yeah.
Professor
See it all.
Berkins.
See you upside down.
Here, I can help with that. Hold on, let's see. If I do stop video, does that mean you guys don't see the share?
It's like
No.
a profile picture or something.
No, you don't see the screen, or you don't see me.
We don't see you, but we can
We
still
don't see
see
you.
your computer.
All right, fantastic. Okay. Sales.
Who's the woman
What's that?
in your picture?
What?
Who's the
It's
woman in
showing-
your picture, she said?
Instead of your video, now it has like a picture of you and this woman.
I have no idea.
I guess a profile picture.
Share screen.
Me, it is. All right.
I have no idea.
Literally, I don't know because I can't see it. I guess if I do this really quick and then back to the problem. Oh, that is Haley Atwell.
Oh.
Okay. Let's see. So sales production or sales function, sorry. Find the point of diminishing returns. So that is the second derivative test. So we need to find first derivative. Somebody want to help me out with that?
75.6x minus 1.8x squared.
Okay. And so then we need x double prime. So 75.6 and what, 3.2 x.
3.6.
What's that?
3.6
Yeah, I'm losing
versus
it.
3.2.
I'm losing it. There we go. Set that to 0. 75.6 equals 3.6x divided by 3.6. And what's that come out to be? My calculator got to.
21.
What was it?
21.
21. Oh, that's
Exactly.
nifty. So let's see. X represents thousands of dollars spent. Question says enter the amount spent on advertising as well as the sales. So this is X, right? That's the amount spent. We just need to plug it back into the original.
Yeah, I think so.
And again, at that point, it's just a calculator doing the work for you. If someone wants to calculate that, I'll write it down. But
That's my kind of math.
what, where you just plug it in and punch it in the calculator?
Yep.
I think heard somebody say 4 and 5. So 4 terminal intervals on which the function is concave upward and concave downward. So this, you just got to look at the graph. They give you points here. So this is at -5. That's at 1. That's at 2. And those are the points that the curvature changes. So those are given to you as the inflection points. All right, so this is -5, -1, +2. So where would you say it is concave upward?
-5 to -1.
So that's actually going to be concave downward, right?
Yeah, okay. A negative infinity to -5.
Yeah,
That's what you said?
sure.
That's what I heard.
Yeah.
All right, so up from -infinity to -5.
And -1 to 2.
Yep.
I always forget that they flip.
You gotta think of it like going from left to right. Like you start up and you go down, and that's up.
Yeah, you have to read the graph from left to right.
Yeah.
Yeah, when we talk about the curvature, it's not that it's moving upward and then downward. It's that it's opening up or opening down.
Yeah.
All right, determine the x coordinates of any inflection. Well, we just did that, right? I said that they're -5, -1, and 2.
That's it.
Yeah, that's all you had to
Cool.
do. Just read it right off the graph.
Cool.
Consider the function, find the second derivative, then locate any local max or min. So second derivative, let's do that real quick. While I'm doing that, how do we find the max or min? clue. Nobody's got their notes in front of them to read off of. Am I watching a movie?
There's a lot of love going on.
Ew.
What, Me is a movie? Is that what you meant?
What? Because she said she might do it.
I think isn't like the min and max like the opposite of what you'd expect? Isn't like
Brad, what the heck?
What?
What were you watching?
It's just a TV in the background. I don't know. It was on since I fell asleep. I almost missed the class, and I had one job to get on my phone.
Brad. Don't you set the second derivative to 0 and then test the intervals?
Is that a question, or you're telling me how to do it?
Probably well, no, because it's, I don't know. That was a question.
Anybody else want to weigh in? Any thoughts? Trying to figure out where I did this in your class. I can refer back to it. If it's, I think it's in 4.1. Personally, I think it's silly to do it with second derivative, but
Yeah, don't you usually only take the first derivative when you're texting for a local max or a min?
you can do it with the first derivative just as well. So that's why I always said I'm not sure why it's important. So if you, so yeah, we actually have to find the first derivative equal to 0 because we have to locate the critical values. And then if the second derivative is positive at the critical value, it's a local min. So yes, you were saying it was backwards. And if the second derivative is negative, then it's a local max. But we still have to locate the critical numbers regardless. So I need to take this equation right here, set it equal to 0. So that's gonna divide these by 2, leaving an 8. Then I'm going to take this square root of x and put it over here. That's going to result next to the 3/2. And so x is equal to 8 to the 2/3. That's going to be 4. So the critical value is 4. We then plug it in to f double prime. I forgot to make this a square. There we go. And plug it in down there. So I don't really care what this number comes out to be because I don't know what the cubed root of 16 is necessarily. It's not going to be something nice. So regardless, it's positive. Which means x equal 4 is local min. And that is in 4.1. If you guys wanted to go back and review that.
Don't we have to have that number so we can make it like an ordered pair?
If it asks for the ordered pair, then yeah, you would plug this back into the original equation.
Gotta pee.
So you would do
Gotta pee.
F4. Doesn't everybody just love working from home?
No,
All right, here.
Nope.
Okay.
I quite hate it actually.
You're crazy.
You guys would enjoy it. My
You can handle that.
cat threw up a hairball during my first class this morning.
No, we missed it.
Yeah, if you want to order a pair, it'd be that, as long as I'm not going nuts again.
Yeah, that's it.
Yeah, as in you looked at the bottom of the page.
Yeah, the answer key.
Okay. Whew, I can do math.
I have a question though about that.
Yeah.
Can you? Yeah, thank you. Where did okay, when you took the first derivative, you have 2 plus 8 over that cubed root funky situation. But when you put it up top and you took the second derivative, you put an x in with 2.
You're talking about this guy?
Yeah.
Okay, so it was square root of x, which remember is x to the 1/2.
Right.
So when you differentiate it, you get 1/2 x to the minus 1/2.
X. Okay.
The negative 1/2 tells you that's a square root, and it's in the denominator because of the negative. So I rewrote it that way. However,
Okay.
I had to take another derivative. So I had to go back to this form.
Right.
So this is now really negative 16x to the minus 1/2. You would bring the negative 1/2 down, subtract 1 from the power, and it becomes negative 3/2.
Okay.
And then again, you put that. Oh man, I put that in the wrong order down here, didn't I? Yeah, this should be square root and cubed.
Haley?
Thankfully, that didn't hurt us because I didn't really have to find the number. But I mean, I can do it now. It's real simple because that's just going to be 3.
Okay. So above all of that is when you got 4, is that you setting it to 0?
Yeah, so I set it to 0, and then I came down there, and I then moved the negative 16 over square root of x to the other side of the equation and made it positive. All right, so right here, divided both sides by 2.
Okay.
Then x times x to the 1/2, add the exponents. That becomes
Right.
3/2.
Wait, x times x to the 1/2.
Yeah, so x times x to the 1/2. This is x to the 1. You add the exponents.
Okay, I follow. Yeah. Okay, cool.
And so then to get rid of this, I would take the 2/3 power of both sides. And then 8 cubed root of 8 is 2. And then 2 squared is 4.
Okay. Yeah, that's okay. Cool. Thank you.
So I'm trying to save this. I'm not sure if I'm hoping it's going to save with all the notes, so I can put that up for you guys if you like.
You know what I found?
So it looks like we got about 25 minutes left.
I do.
You just want to keep going.
I found secret stash in there.
Are there any harder ones towards the end?
In there.
I don't know. I mean, I don't know what you guys find hard. I think it seems to me like the hard stuff for you guys is honestly the algebra.
Yeah.
Yeah, the algebra is definitely tough. Or like the multi-step ones where we have to do like multiple steps.
So like this, I mean, I have faith that you can find the derivative, but it's cleaning it up, you know, and getting it down to this for the second. That's, I think, the hard part. You know, I haven't worked every one of these out yet, so I can't tell you which ones are super algebra intensive. I can try and look and see if I see anything that looks
There's some big ones towards the end on that third page.
big ones, as in word problems.
Some of them, yeah, and then the differentials ones. We go over one of those.
So yeah,
And then
I'll do
one
one
of
of
the-
these, and then maybe I'll go back and do one of the word problems if you guys like.
Yeah, do that.
All right, so let's just do 20, I guess. So consider this function. Let me just make some space. Whoops. How do you guys like this format as opposed to working on the screen?
This is better.
This is way better.
Just
Much better.
easier to
Yeah.
see.
And we can screenshot it.
Yeah, you could do the other. You could do the same thing with the other method, the screenshot.
It was really hard to see that though.
Yeah.
I
It's
think
just because of the lighting.
All right. So consider the function using these values. Calculate delta y minus dy. So first, let's find dy. That is simply the derivative of this function. So that's 2x plus 2 times the differential dx. And then we also need to find delta y. So I'm going to ask you, how do we define delta y? Again, I'm going to grab the notes here. I think this is 4-5 that we did, in case you want to refer back. No, maybe not. Maybe it's 4-6. Yeah, 4-6 is the unit for this guy. So does anybody remember how we find delta y? Either everybody got really quiet or I lost everybody. I'm not sure.
I'm here.
So it's that equation there. That was that difference quotient that we used earlier in the semester. So let's go ahead and plug this stuff in. So this is really f of x, if you prefer. So this is x plus delta x squared plus 2 times ooh, screen just got really bright. Apparently my charging wasn't working properly. All right, 2 times x plus delta x plus 7. So all I did was, if this is f of x, everywhere I see an x, I put a set of parentheses. Sorry, I'm using the wrong mouse. All right, this is f of x. So if there's an x here, I just put x plus delta x in its place. And then there's an x there. I put x plus delta x. And then finally, it's minus the original function. So minus that whole thing. Now you could go ahead and square that out and do all that math. I'm assuming you guys are going to be very resistant to that. So let's go ahead and plug numbers in, because I know that's what you like to do. So this is -2 plus 0.6 squared. 2 times -2 plus 0.6 plus 7 minus -2 squared plus 2 times -2 plus 7. Would someone mind calculating that, please?
That whole thing?
Sure, if you don't mind. If you want to do a portion of it, that's fine too.
We just took the dogs out.
I'll show you how I do this kind of stuff in my head. I would write 0.6 that way. And then that multiplication is easy, or you could do just this here is that. Either way works out. So now this is dy. And anybody get something for?
I don't know if I did it right, but I got -0.84.
Yeah, that's what I got for the whole thing.
Yeah.
Right here you got -0.84.
Yeah, for all that.
Okay. So then it says in the problem, calculate delta y minus dy. So delta y minus dy, -0.84 minus -1.2. So 1.2 minus 0.84 is 0.36.
And the answer has it as 360.
360?
Yeah, where'd they get that third? Why? Oh, 3 decimal places. But it wasn't necessary.
Yeah, I know. Don't ask silly questions. I'm kidding.
Okay.
I'm sure it just says that for all of them. Right, and they don't all work out nicely.
Oh yeah, it does. For like 20 to 22, they all say that.
Listen, somebody created this website for her. Somebody created the email for her.
All right, so let me go back. Or any
Would
questions?
they make
really
that
quick?
wrong if you put in 0.36 online?
If it's
360.
if it specifically says round your answer to 3 decimal places and you don't put that extra decimal place, it will most likely mark you wrong.
Okay.
But that's why I'm having you send me your notes.
Gotcha.
So that way I can go back in and go, well, it looks like they got it right. They just forgot to put the 0. And I
Yeah.
probably,
So we're still gonna get like partial credit for problems and stuff.
that I'm going to try to give you as much credit as I can. Yes.
Okay, cool.
All right. So what other problem did I say I was going to do? One of these up here. So right, this problem, you just kind of need to know the formulas. There wasn't really any labor-intensive stuff there. It was take a single derivative and then know this formula so that you can plug all your numbers in. It's an error. Now there should be another period there. All right, the top and the bottom will cost this much. The sides this much. It should be the height of the container to minimize cost. Do you guys want to try this one?
Yeah.
Yeah, it's not going to be enough room. All right, so it says rectangular boxes. So let me use my art skills here. Oop. Uh-oh, my pen's not working. Yep, pen died. Let me try to save this and close it real quick. Let me take out the battery and put it back in. Try that first. I need to get a battery. This thing takes quadruple A batteries.
I have one of those. The battery, like, you can't find them anywhere.
Don't tell me that.
I've
Never
struggled
even-
to find them.
I've never even heard of that. Quadruple A batteries.
It's
I don't think
so
I've ever seen
small.
one.
Yeah, they're a little bit smaller than a triple A. All
Why
right.
can't they just use? Why they gotta make it difficult?
Because the design of the pen, I guess. They didn't want to make the pen too big. Oh, it's terrible. I got to start over. Much better. Okay. Bottom and top measure 3x by 2x. So I'm going to call this length 3x and this length 2x. And then container must contain 24 cubic inches. So that tells me that the volume is 24. Top and bottom will cost $1.70 per square inch. Okay, so square inch tells us that we have to do the area. So it would be $1.70 times 3x times 2x plus, this is our cost. It says the 4 sides will cost $3.60 per square inch. Now, two of the sides are going to have 2x at the bottom. And they're going to have height h, because notice they say, what should the height of the container be? So that's the thing we're trying to find. So let's see, we've got 3.6 times the two sides, which are 2x by h. And then there are two other sides that are 3x by h. Everyone okay with where I got all those values?
Yeah.
Okay. And then the volume has to be length times width times height. So this is really what, 6x squared h. We're trying to find h to minimize. We could go ahead and plug in for h in terms of x. Find x and then go back and solve for h. Or we could start by solving for x. Now I do see if we do that here, that's going to be a little problematic. So right off the bat, we can simplify this and make this 4 equals x squared h. Now, if I try to solve that for x, I would get this. So I'm thinking we probably want to go ahead and solve for h instead. So then we come down here and let's simplify this cost equation before we plug in. So this is 1.7 times 6x squared plus, then we got 3.6 times 4xh plus 6xh. That's 10xh. So let's see what's 1.7 times 6. This is 10.2x squared. And this should be 36xh. Good with all that so far.
Can you just go over where you got all those numbers in that?
Cost equation.
Yeah, all those in the brackets.
Yeah, so it says 1.7 per square inch. Square inch represents area. And so the area of this side per se is 3x times h. And there's two of those sides. So that's why I have 3xh times 2 in there. And then this side is 2x by h. So I have two of those. Oops. Come on, pen, what are you doing? You okay with that?
Yeah. I mean, it like makes sense when you explain it, but whenever I look at it, like I can't just pull it out of my head.
Well, that's what you need to practice with, I suppose, then.
Yeah.
And I mean that as in, if that's the thing that's holding you up, then that's what you got to, take these, word problems here and just try and break them down piece by piece like that.
Yeah.
So everybody else good so far? Take that as everybody's
Yep.
away from
Yeah,
Mike.
I'm good.
Hey,
Thanks.
we're good.
All right. So let's finish this guy up because we got 4 minutes left. I need to find C. First off, I got to plug H in. So H was 4 over x squared. Dang it. 10.2x squared plus 36x times 4 over blah, 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 x squared. There we go. So that's going to make one of those x's cancel there. What is that, 144? Yeah, I should have known that right away. So 10.2 x squared plus 144 over x. Then we need to find C prime. C prime is 20.4x minus 144 over x squared. If you don't know what I just did, remember that 1 over x is really x to the minus 1. Take the derivative of that guy, you'll get what I got there. Got to set that to 0. So let's solve that. Oops. 144. 20.4. See if we can figure out what that is. So 144 divided by 20.4. It's a nasty number. Irrational. And I want to take it to the 1/3 power. And I get something like so part of me is hoping I may have made a mistake here. And I say that because that number is not very nice. So we'll check the answer here in a second. The only thing I would have to do to find H now is to just take that, plug it back in there.
It's wrong.
Fantastic.
It's 1.73 inches.
For H?
Well, that's literally the only thing it says. So is that maybe H? Here, let me find
Yeah, I
out.
haven't found H yet. So
4
4,
divided by
and it's
1.8
1.918. I got
squared.
2.085. Oh, wait, sorry. I got to square that number, darn it. 1.918 squared. 4 divided by that number. So I did truncate. I got 1.087.
Yeah, that's what I got too. The answer is 1.73.
73. So that could be that because of the truncation. Right. If I start like right here, I truncated this number.
What does that mean?
Let's do this. Let's say H then is really the 4 divided by the cubed root of 144 over 20.4 quantity squared. Let me find my calculator really quick so I can get a more accurate value there and make sure that we got it. You know what I think I did? I think I missed one thing. Top and bottom will cost $1.70. I only did one of them. I missed a 2 there.
See, these are hard.
It's not that hard. You just gotta realize when you make a mistake. All right, so let me just quickly fix this. And then, I mean, if you guys got to go, obviously you can go. Come on, pen. I'll just fix it and finish the recording. So that's going to make this guy.
These are going to be recorded, correct?
It's recording, but I have to figure out how to put it up now. I don't know where it's saving the recording. Yeah, I don't know anything about how that works yet.
Gotcha.
So that is one slight downfall. Okay, C prime. So be 40.8, which means this is 40.8. And so is this. I think I've effectively changed that all the way. I'm just going to use my phone real quick and hope it'll give me a nice number. 144 divided by 40.8. Hold on a second. So 144 divided by that. Let's go ahead and square it. Then take the cubed root. And then all right, what'd you say you got, or what was the answer?
1.73 inches.
Oh, yeah. So this is the long number I get. And that rounded 1.73. All right. So,
Can you scroll up a little bit, please? Just so I
can I scroll up, you said?
Yeah, just a little bit.
Okay.
Thank you. Yeah, that's good.
All right, so I'm going to go ahead and stop the recording, but I'll keep the meeting going for a minute.